Hi guys, this is Andrew Worm, whatever you want to call me, from Worm's Maths Academy. I had quite a few people message me and say, can you please do 2017 Exam 2 Extended Response? So, that's what we're going to do now. I didn't actually do this last year, but my students were, um, what's the word? They weren't very happy when they came out. They just, they came out pretty depressed, I think. It was reasonably hard exam. Okay, so all questions in the answers provided. More than one mark is available. You must show working out. Diagrams are not drawn to scale, and exact value must be given unless otherwise specified. Okay, x cubed minus 5x, part of the graph is shown. Find the coordinates of the turning point. Okay, so chuck it into the code. Stupid thing. Okay, so x cubed, was it minus 5x? Don't know. Actually, I need to be really quick with this one. So let's define f of x. Okay, we had a maximum that was between, say, -2 and 0. So advanced calculation f max f of x. And that was between -2 and 0. Somewhere around there. And then we had the same thing, but it was f min, and that was between about 0 and 2, because it sort of looks symmetrical. F min, I've got a feeling it will be symmetrical, so 0 to 2. Okay, so -√15 on 3 and 10√15 on 9. -√15 on 3, 10√15 on 9, and the other one was √15 on 3, -10√15 on 9. Okay, that 10 was on 9 as well, so I've got to fix that up. 10√15 on 9, -10√15 on 9. Okay, a is -1, f of 1, b is 1, f of 1. 2 points in the graph of f of x. Find the equation of the straight line through a and b. Okay, so a is -1. What's f of -1? It's 4. B is 1. Let's guess, -4. So m is 4 minus -4, which is 8, on -1 minus 1, which is -2. So our gradient's -4. It's going to go through the origin. So y between a and b is -4x. Find the distance a to b. Okay. Distance of AB is the square root of 4 minus -4. Oh, we don't need to do this because if you think about it, it's been moved 2 across and 8 up. So 8 squared plus 2 squared. 64 plus 4 is 68. Which is 4 goes into that 17 times, so 2√17, that's my distance. It's 1 mark, that's why I didn't bother. Okay, x cubed minus kx. K is an element of r plus. So we can change, edit copy, go down, edit paste. That's a G, and that's a K. For some reason it always puts in a Z. Okay, so let's just check that, make sure nothing's stored in K. Okay, find the distance in terms of K. Okay, so C is a point -1. Now if I put negative 1 into that function, I'm going to get negative 1 plus k, or k minus 1. D, 1 is going to give me 1 minus k. So the distance from C to D is the square root of k minus 1 minus 1 minus k, so minus 1 plus k squared, plus negative 1 minus 1 squared, which is, okay, square root of so we'll say f of negative 1 minus f of 1 squared plus negative 1 minus 1 squared. What? That's supposed to be a g. Simplify. 2 root k squared minus 2k plus 2. 2 root k squared minus 2k plus 2. This is probably the hardest question I've started with for a while. Find the values of k such a distance CD is equal to k plus 1. So we just want to set that equal to k plus 1. Solve for k. Stupid thing. K equals 1 or 7 on 3. Okay, k can be what? Where is it? K is an element of all real positive numbers, so those two values are okay. Find the value of a in terms of k. So I've got this point here, and I've got this point there where they intersect. So g of x equals x. Solve for x. Okay, 0 root negative k plus 1, root k plus 1. So a equals root k plus 1. Because we know it can't be that value. It would be another value back here somewhere. But we don't care about those because we're only looking for the positive value. Find the area of the shaded region in terms of k. 2 marks. So we're going to go from 0 to root k plus 1. The higher function is x minus g of x dx. So higher function minus lower function over the domain. Integral from 0 to root k plus 1 of x minus, because we've got g of x defined, dx. Simplify. K plus 1 squared on 4. I reckon that's a good answer because it seems nice once it factorizes. What was I going to say? Okay, so now question's done. Let's go back in. I'm going to delete f and g. Obviously I haven't defined k, so and clear this off. Next question. Okay. Sammy visits a giant Ferris wheel. Sammy enters a capsule on the Ferris wheel from the platform the ground. The Ferris wheel is rotating anti-clockwise, which is that way. The capsule is there. Okay, so his height's modeled by that, where t is the time after h is measured in meters. Sammy exits the capsule for after one complete cycle. Okay, state the minimum maximum height. So your center is 65. You add 55 and you subtract 55. So we're going to get 120 and 10. So let's say min 10 meters, max 120 meters. Find how much time is Sammy in the capsule. So that's going to be 2 pi on 15, which is 30 minutes. Do this on your calc if you're unsure. I just can't be bothered switching between screens. Find the rate of change of h with respect to t, and hence state the value of t for which the rate of change of h is a maximum. Okay, so this is where we want to define it. 65 minus 55 cos 15. 65 minus 55 cos pi x on 15. Define it. Now, why did I define it? Because I want to derive it. So negative 55 cos 15. Just make sure you've got it right so you don't stuff it up. Okay, so we want to derive that. So d dx of f of x, 11 pi on 3 sine pi x on 15. H dash of t, 11 pi on 3 sine pi t on 15. Now we want to find when that's got a maximum, so we're going to need that, and we'll just grab it anyway. Edit, copy. Oops. Now make sure you calculate it in radians, which it is. What's the period? 30. So we're going to go from 0 to 30. Zoom. Auto. Do solve max. So 7.5. That's when it's got a maximum. And hence state the value for which it's a maximum. So we found the maximum of that. T equals 7.5 minutes. Okay, as a Ferris wheel rotates, a stationary boat at B on a nearby river first becomes available at the point P1, so that's when we're here. B is horizontally 500 meters, which is up there. CBO, okay, so that's our angle we want to find, I'm assuming. Find theta in degrees, correct to two decimal places. Okay, so I've got that. Obviously we know what the center is because I worked that out before. That's 65. So that's 65. So we know tan theta is 65, 500. Therefore, theta is in degrees, two decimal places. So tan inverse. Where are we? Tan inverse of 65 divided by 500. What do I want? Degrees. Oh, you stupid thing. 7.41 degrees. Oops. 7.41 degrees. Okay, the path of P is given by that. So that's this circle around here. Oh, it's actually the whole thing. Oh, what? Okay. Okay, find dy dx. So y equals root 3025 it's going to be minus x squared and then plus 65. Define that as g. Oops, define. Okay, so that's g of x. Let's make sure I didn't stuff it up. Plus 65. Okay, find dy dx. d dx of g of x. Don't do it decimally, do it nice. Negative x on root 3025 minus x squared. Okay, as the Ferris wheel continues to rotate, the boat at B is no longer visible from the point P2, UV, onwards the line through B, through here, and P2 is a tangent. Okay, so we've got the derivative, which is the gradient of the tangent. PUV, so that's P2. I'm going to say that that's U, and my V value is actually, where the hell is it? That 3 root 3025 minus U squared plus 65. So that's that value because it lies on that circle, and when we sub U in, we're going to get that. Okay, so we know what the gradient is. That's that. And we've got that point, and it's got to go through that point, which is 500. Oh, 500. Okay, so it's got to go through that point. It's going to be 500 and then 0. Okay, so we can say m of P2 to B is equal to y2 minus y1, which is 0. So root 3025 minus U squared plus 65 on U minus 500. So that's our gradient between those 2 points. And we also know that dy dx, find the coordinates, okay, dy dx is equal to negative x on root 3025 minus x squared. So they've got to be equal. The two gradients have to be equal. Find P2B in terms of U. So I found P2B in terms of U. Hence find the coordinate. Okay, so let's have a look. So square root 3025 minus x squared plus 65. Is that right? On x minus 500 is equal to that. So the two gradients are equal. Interactive advanced solve for x. That doesn't matter. Okay, so 12.997 U equals 12.997. Oh, but it says correct as 2 decimal places. Therefore, U is 13. Okay, so G of 13, because G is the circle. Copy. Actually, we should do G of this whole thing. 118.44. P2, the coordinate, 13.00, 118.44. I should do that to 2 decimal places. So U equals 13.00. Okay, find alpha in degrees correct to 2 decimal places. I'm going to change colour just to see. So we can't use that because we don't know what that right angle is with this. But we know what that height is, or we know what that length is because it's the radius of the circle. Do we know what that is? Alpha is the full angle. That's not 500, because that's 500, so that's not 500. Think brain. And we could find that intersection point. Let me think about it. What am I going to do? What's the easiest thing to do here? I could find the equation of that line, find the y-intercept, and then use tan inverse. Let's do that. So, u, v. So I want the equation of the tangent at the point 13, or 12.99. So, equation of the tangent of g of x at that point. Calculation line, tan line. So I'll say 12.99748201. Oops, but that is g of x. Okay, so that's my y-intercept, 121 point. And we know that the angle tan theta is that over 500. So tan, what the hell did I just do? Tan inverse of that divided by, is it 500? $13.67. Don't have to show how we worked it out. So 13.67 degrees to 2 decimal places is what I'm thinking that angle is. So we worked out that length, and we worked out that length. We know that length is 500. So we found the angle alpha is 13.67. Hence or otherwise, find length of times the nearest minute for which the boat B is visible. Okay, so we could find out, let's get rid of this. We could find out it's from here, and the other point is here. So we can work out what that angle is, because it'll be alpha minus theta. So alpha minus theta gives us 13.67 minus 7.41 minus, let's see if we've still got that, copy, paste. Okay, so 6.26 degrees, and the other one's 90. So if that's 90 and that's 6.26, then that one's going to be 90 minus 6.26, 7.41. So therefore, let's say beta is equal to that. Beta is equal to, what did I get? 6.26. So let's say this is, I don't know, what do you want to call it? Theta P. So theta P is 90 minus 6.26 degrees, which, assuming I haven't stuffed anything up, it should give us the angle that's on the inside. So 90 minus that gives us 87.74. what did I say? 83.74. Okay, so that is, find the length of time. So that's 83.74 out of 360 degrees times 30 minutes. Hopefully this is right. 360. So that's the fraction of a circle, 83 degrees, times 30 minutes. So 6.978 to the nearest minute. Therefore, B is visible. Visible for 7 minutes. That sounds familiar to me. I remember students getting something like that, so hopefully I haven't stuffed anything up. Not a very nice question. Okay, let's clear all our variables again. Now this doesn't look very nice. Spends time on her homework each day, but she does some homework every day. The continuous rate of variable t models her time. Jennifer spends each day on her homework, probability density function. So she spends between 20 and 75 minutes on her homework, 0 otherwise. So you've got to put, wasn't very straight, you've got to put 0 there, and then 0 there, because it says 0 otherwise. Okay, this starts at 20, so when I put 45 into that, I'm going to get 20. Actually, let's just define them. I'm going to call this f of x, and I'm going to call this g of x. So 1 on 625, was it t minus 20, x minus 20? That would make sense because it's positive, and it would be 0 define f of x. Then the other one was a bit similar, but we'll call it g, and I think it was 70 minus x. Okay, I'm just going to sketch them to make sure they're right. A couple of minutes at the start sketching them can save you a lot of time if you've stuffed something up or if you've got something to find. Okay, what do we want it between? 0 and 75, we'll say. Zoom auto. Okay, so there's our graph. Looks like it could be right. It's symmetrical, so if I put 45 into it, I'm going to get 25 divided by 625, which is 1 on 25. So that's going to be at 45. You could if you wanted to, right? 45, 1 on 25. Okay, find the probability that 25 is less than t, which is less than 55. So I'm just going to say 25 to 55, f of t dt is equal to, now this function, because for some reason it stuffs up on these calculators, so I'm going to go from 20 to 45 of f of x dx plus 45 to 55 of g of x (41 on 50). So that's that area there. Find the probability that t is less than 25, given that it's less than 55. So that's the probability that t is less than or equal to 25 intersects t is less than or equal to 55 over the probability that t is less than or equal to 55, which is the integral from, not 0, 20 to 25 of f of t dt, don't forget your dt, from 20 to 55 f of t dt. Okay, so we need to find less than 25, which I guess we did sort of here. 25, so that's 1 on 50, divided by between 20 to 55. So 20 to 55. Before I did, that's supposed to be 25, or is it 20? 25. I can imagine heaps of people stuff this one up. So 25 to 55, that's 4 on 5, because I did 20. Okay, so 1 on 50 divided by 41 on 50, because I found that out before by accident, that's 1 on 41. So that's the probability that t is less than 25, given that it's less than 55. Okay, find the probability of a such that the probability of t is greater than a is equal to 0.7. So t is greater than a is equal to 0.7. So just say the area has to be 0.7. So less than a is going to have to equal 0.3. So what I would do is go from 20 to a of f of t dt and let it equal to 0.3. Therefore, a is equal to, okay, so let's go from 20 to y, f of x dx equals 0.3. Solve for y. Correct to 4 decimal places. So it can't be that, it's got to be 39.3649. So if a is greater than 39.3649, no, if a is equal to that, then the probability t is greater than a is that. Yep. Okay. Probability that Jennifer spends more than 50 minutes on her homework each day is 8 on 5. Find the probability. Assume the amount of times when her homework is independent. Okay. Find the probability that Jennifer spends more than 50 minutes on her homework on more than 3 of the more than 3. Okay, so we can say x is binomially distributed with n is 7, p is 8 on 25. The probability that x is more than 3, so greater than or equal to 4, is, okay, interactive distribution, discrete binomial CDF, 4, 7, 7, 8 divided by 25, 0.1534, 4 decimal places. Okay, that seems right. Find the probability that Jennifer spends more than 50 minutes on homework at least 2 of 7 random. Okay. At least 2. Given that she spends more than 50 minutes on at least 1. So the probability that x is greater than or equal to 2, given x is greater than or equal to 1, is the probability that x is greater than or equal to 2 intersects x is greater than or equal to 1 over the probability that x is greater than or equal to 1, which is greater than or equal to 2 over the probability that x is greater than or equal to 1. Okay, greater than or equal to 2 is 2.7113 over greater than or equal to 1, because we're going from 1 to 7, 0.9328 which equals, don't forget to use the whole value, so let's put that on the bottom. Let's put that on top with a 2 instead of a 1. Oh, 0.7626. Okay, so that's a probability that she spends more than 50 minutes on homework on at least 2 of the 7 random chosen, given she spends more than 50 minutes. Yep. Let P be the probability that any given day Jennifer spends more than D minutes on her homework. So let's say D so this is binomial. More than D minutes on any given day. Q, so what have we got? P, what am I thinking here? So we can just say Q the probability and 2 or 3 are so okay, so Q in terms of P is equal to 7 randomly chosen days. Okay, so 7, choose 2. P is the probability she spends more than D. So the probability that she spends greater than D minutes is equal to P. So in this case, that's P to the 2, 1 minus P to the 5, plus 2 or 3, 7C3, P to the 3, 1 minus P to the 4. So therefore, Q is equal to, okay, so let's do that. What am I doing? 7, 2, times x to the power of 2 times 1 minus x to the power of 5 plus the same thing again, I'm just going to do that plus that, I'm going to change this one to be 3, and 4. Simplify. Okay, so 7p squared, x minus 1 to the p, 7p squared, p minus 1, did I stuff that up, to the 4, 2p plus 3. So that's Q in terms of p. Find the maximum value of Q, correct the 4 decimal places, where the value for P, okay, so I want to find the maximum value of that function. 7P squared, P minus 1 to the 4, P plus 1. We're just going to find the maximum value of that function. So it's got to be between 0 and 1 because it's a probability. So let's do calculation F max from 0 to 1. Find the maximum value of Q and the value of P for which this maximum occurs. Okay, So the maximum value of Q Q 0.3539, and then Q is our actual maximum value, which is 0.5665. Okay. I can't really think of what working out they'd want to. I mean, they could say Q dash of P is equal to 0, therefore Q is equal to that. Find the value of D for which the maximum found in part G2 occurs. So find the value of D so we want to go from more than D minutes on our homework, more than D minutes. And the area is 0.3538. Because it's symmetrical and it's 0.3538, it's got to occur after 45, because there's 5 there and 5 there. So we know we've got to go between D and 75, and that's got to equal that P value, which is 0.3539. So if we go from D to, is it 70? F of T dt equals 0.3539. Find the value of D. So I know that that's G of X. Okay, so G of X from Y to 70 dx is equal to that value. Solve for Y. Okay, 48.9676. It can't be 91 because it's too big. So 48.9676. D equals 48.9676. Therefore, D equals 49 minutes. Correct to the nearest minute. That was wrong, wasn't it? Oh, thank God that question's finished. That seems really long for a probability question as well, and annoying. How many questions is there? Last one, thank God. Okay, f of x is 2 to the x minus 1, x plus 1 minus 2, so let's clear it all and start again. Okay. 2 to the x plus 1 minus 2. 2 to the x plus 1 minus 2. Define it as f of x. Okay. So to go from that graph to that graph. Okay, so that's f of x plus 1 minus 2, not d, I don't know, 2 d's from the last question. Okay, so that's been moved 1 to the left, so c has to equal -1, because remember when it's like this, it's just the value that you want to move it left or right, and in this case it's left 1, so you put -1. D is the translation down, so it's going to be -2. Okay, find the rule and domain for f inverse of x, the inverse function of f of x. Okay, so f inverse of x, oops, is so I would say x plus 2 on 2 log 2 minus 1. So log 2 of x plus 2 on 2 minus 1. And then our domain is negative 2 to infinity. So I might move it over. So f such that what do we want? Negative 2 to infinity from, from the real number set. F of x is log 2 of x plus 2 on 2 minus 1, because my domain is the range of the original function. And I put f of x, I meant f inverse of x. And then that should be an inverse as well. Okay, find the area bounded by the graphs of f of f and f inverse of x. So f of x equals f inverse of x. Therefore, x is equal to... Okay, so let's define it as g of x. What was it? I might not finish this exam in time. Log 2 of x plus 2 on 2. Log 2 of x plus 2 on 2 minus 1. Interactive define g of x, g. Okay, so if we let them equal each other, solve for x. Have I stuffed something up? X plus 2. It's not on 2, it's just x plus 2, I think. Yeah. That's what you get for not doing it properly. X plus 2. So that's just x plus 2. Okay, so x equals negative 1 or 0. We probably should have checked to make sure that the graphs are right. So sketch. Zoom, initialize. Okay, so if we zoom in, it looks like it's at negative 1 and 1, doesn't it? Okay, so then we want to go from negative 1 to 0 of f inverse of x, because that's the upside down graph, minus f of x dx, which is sorry, I've got a really bad habit of clearing the screen. Negative 1 to 0 of g of x minus f of x dx negative 2 on log e2 plus 3. So that's the area, which seems much nicer than that decimal answer I got. Okay. Part of the graphs of f and f inverse are shown below. Find the gradient of f and the gradient of f inverse at x equals 0. So f dash of 0 is equal to d dx f of x given x equals 0 to log e2 so f inverse, so do the same thing but this time we use g, 1 on 2 log e2. Okay, so one's the reciprocal of the other, the inverse is. The functions g of k, where k is an element of all real positive numbers, are defined with the domain R such that g of k is 2 to the e to the kx. Okay, find the value of k such that g of k is equal to f of x. So we want 2e to the kx minus 2 to equal 2 to the x plus 1 plus 2. Plus 2 or minus 2? Minus 2. That makes it a lot easier. So therefore, 2e to the kx has to equal 2 to the x plus 1, which means 2e to the kx equals 2 times 2 to the x, so they cancel. So e to the kx has to equal e to the 2x, so e to the k equals 2, because that and that have to be equal. So therefore k is equal to log e of 2. Find the rule for the inverse functions. There's more than one. G inverse of k, g of k. Okay, so gk inverse of x is, so it's going to be x plus 2 on 2 log e 1 on k. Log e x plus 2 on 2 what we can do, I'll show you another thing is, so we've got 2 e to the kx k times x minus 2, define it as f of x. Okay, then we can grab this, change that to y, let it equal x, solve for y. Okay, so 1 on k log e x on 2 plus 1, 1 on k log e x on 2 plus 1, same thing. Okay, define the transformation that maps g of 1 onto the graph of g of k. What the hell is g of 1? G of 1. So does that mean k is equal to 1? G of 1, so g of 1 of x is 2e to the x minus 2. G of k of x is 2e to the kx minus 2. So that would be f of kx, which is a dilation factor 1 on k from the y-axis, because when it's inside, it's from the y-axis, and it's always the reciprocal. Describe the transformation that maps the graph of G inverse of 1 to the graph of G inverse of k. G inverse of 1 of x, so that's that, which would just be log e, x plus 2 on 2, and then it becomes that, so it's going to be 1 on k. I could say, I'll get rid of that. So it's a 1 on k at the front, which is a dilation factor, 1 on k, this time from the x-axis, which makes sense because they are inverses of each other. Okay, L1 and L2 are the tangents at the origin of g of k and g of k inverse. Have I got g of k? Okay, so that's g of k inverse. Define that as g. Okay, because I've got a k and they're going to say given k. Then I say here, undefined variable, oops, that one. Okay, so we know k has to be positive, so we can draw their tangents, I guess, at the origin. So there's one, and then over to the other one, it's going to go. Okay. So L1 and L2 are the tangents at the origin. So. Let's say G dash of K. What's that equal to? Because it's going to go through the origin, the y-intercept's going to be 0. So d dx of f of x is 2. Hang on, have we got k defined? I think we have. Because I think it's going to have a k in it. 2k e to the kx. When x equals 0, that's going to be g dash of k, 0, is 2k. So therefore, L1 would be 2kx, because it's got to go through the origin. That's a straight line. So g of k inverse dash is, do the same thing, but with a g, 1 on k, given x equals 0, so that's going to be 1 on 2k, which makes sense, it's the reciprocal. 1 on 2, x plus 1, when x equals 0, g inverse dash of k of 0 is 1 on 2k, so L2 is 1 on 2k x. Okay, so find the angles between those is equal to 30. So if this one is equal to 60, the other one will be equal to 30. And then likewise the other way around. So we can say our gradient, 2k, tan of 60, because one's got to be 60, the other one's got to be 30, has to equal 2k, or tan of 30 has to equal 2k. That's because if this is 60, that one has to be 30, and if this one's 60, that one has to be 30, because the angle between them will be 30 degrees. There's no other time that it'll occur because if you graph those graphs, if you graph the tangents, I don't know if I'll let us do it. Tangent, 0, enter. Because you can see if I did a tangent at 0 and a tangent at 0, the angle's going to get bigger. But you can see as I move them closer, there the tangents are going to get, like the angle between them slowly going to become 90 degrees. Okay, so tan of 60 is root 3 on 1. So root 3 equals 2k, so k equals root 3 on 2, that's one solution. Tan of 30 is 1 on root 3. So k is going to equal 1 on 2 root 3, which is root 3 on 6. So it says find the values. So when k equals root 3 on 2 and k equals root 3 on 6, yeah. I mean, we could have 2kx and 1 on 2kx because we know they're the gradients. 2k times x, and then 1 on that. Okay, so if we sketch them, there's our tangents, but let's make our, so you can see here, there's our tangents. Oops. Where's the other one? Oh, it's 1 on 2k and then x. Okay, so if I said go from 0 to 1, and we made our step value of, let's say, 0.1. Okay, so as we change it, you can see that our, back here, our tangents would have had an angle of 30 between them. And now as we continue on, they have another angle of 30 between them. So that's why I got two values. Okay, let P be the value for which K, for which G of X only has one solution. So what they're saying is, let's get rid of these two. When the two graphs, if we sketch them, you can see here there's going to be a value when they only touch once, and it looks like it's that value there, half, because then it crosses over. So when k equals a half, there's only one solution. So let P be the value for which k, so that would be when the tangents are equal. So the gradients of the tangents would be equal. Because you can see there, with the curve, there's the tangent both at 0. So 2k would have to equal 1 on 2k, because the gradients of the tangents will be equal. So 4k squared has to equal 1. So k squared has to equal 1/4. So k equals plus or minus 1/2. What do we know about P? Bloody hell, some of these are. K is positive, so it can't be negative. K is greater than 0. Therefore, K is equal to 1/2. Therefore, P is equal to 1/2, because P is the value of K for which there's only one solution. And we know if we let k equal 1/2 that there's only going to be one intersection point. If I go G solve intersection, there's only one point. But then if I change it, any other value, there's going to be multiple points of intersection. Okay, we must be nearly there. Let A of k be the area bounded by the graphs for whenever k is greater than p, so when k is greater than a half. Okay, state the smallest value of b such that the area of k is less than b. So let's find the area. So k has got to be greater than a half, because p was a half. Okay, so let's change this to go from, we'll go up by ones, and we'll go up to 200. Okay, so what happens, this area in between, I can't draw on it, the area between negative 2, 0 and negative 2, 0, you can see that that area is going to be like a square, right? So, because that graph goes like that, like you've got one graph going like that and one graph going like that, the smallest value of b such that a of k has to be less than b. So what is this area approaching? Because it's got to be just a bit less than it, but we'll never get to it. So b will equal, that area is going to be 2 by 2. So b will equal 4. Then area will never get to 4, but you can see as k gets bigger, it's autoplay. As k gets bigger, it's getting closer and closer to a square, and that square would have an area of 4. But in this case, it never actually gets to 4, but it'll approach it. So as k approaches infinity, the area between those two graphs is equal to 4. So b is that limiting value. Okay, stop. Escape. Okay, so the smallest value of b such that a of k is less than b. A of k is the area bound by the graphs of, okay, so it is those graphs. And k has to be greater than p, because if p was between 0 and a half, it'd be up here, which is no good to us. So it's definitely here and it's definitely 4. Alright, I think that's it. So you can see there, when that goes like that and that goes like that, the area between those two is going to be 4. That was if it's a perfect square, but it can't be a perfect square because it's an exponential graph. Hopefully you've got something out of this. Definitely probably the hardest exam they've ever had in methods. I don't remember any of them having every single question being tricky. I might have a look at the distribution of the scores to see. Actually, I might even have a quick look. So, VCAA distribution, grades, 2017. Maths methods. Okay, exam 1. 35 would have gotten you an A+. Oof. 29 would have gotten you an A. Wow. That exam was really poorly written. Didn't like it at all. Okay, the second exam, 63 out of 80 would have gotten you an A+. And 56 out of 80 would have gotten you an A. And where's half marks? So you needed more than half marks to get a B. That's abnormal. Anyway, hopefully that helped, and don't forget to like, share, subscribe, whatever you need to do on YouTube. I don't make any money because I don't have enough subscribers or anything like that. But anyway, good luck with that exam. Thanks, bye.